Hello everyone, welcome back to another session of building estimate, and we are learning the topic of estimation of other civil engineering structure. So in the previous session, students, we have learned the quantities of septic tank and soak pit, and in the entire lecture series of this building estimate, we have learned the centerline method, long wall short wall method, all the theoretical fundamentals, then numericals of long wall short wall, numericals of center line, fundamentals of reinforcement calculation. Then we have studied about the reinforcement of beam, column with foundation, then estimate of road in cutting and filling, and just in the previous session we have done the soak pit and septic tank. So if you are not clear about all of this quantity estimation, kindly go back to the previous session, watch them, and then come back to this session. So today in this session we are going to learn the quantities of culverts, steel roof truss steel. We are going to learn about more about steel channels and angles for the steel structures, and at last we are going to see some of the other numericals based on road estimate. So let us begin with the culverts. So students, first we are going to learn about Hume pipe culverts. But before learning the quantities of Hume pipe culverts, do you know what are they? Let us see a figure to understand that. So here is the figure of Hume pipe culvert. Yes, this is known as, we have seen everywhere, this is made up of RCC, so these are known as Hume pipe culverts. So I hope now we are very much clear that what you can call it as Hume pipe culverts. So let us begin with our numerical number 1. So here is the numerical. The numerical says that the figure given below shows the details of Hume pipe culvert. Find out the quantities of following items. So first we need to find out the quantities of total quantity of excavation in foundation. Second, cement concrete flooring or cement concrete in foundation. And the third is UCR masonry. Now what do you mean by UCR? UCR stands for uncoursed rubble masonry. Alright, so we need to find out 3 quantities. Let us begin with the total quantity of excavation in foundation, and let us see the figure of Hume pipe culvert. So here is the figure of Hume pipe culvert. The plan and the sectional elevation is given with the dimension detailing. Now students, let me clarify this. When you are seeing the Hume pipe culvert, it is like 2 ways. It is of 2. But when you are seeing that, the only one side is being seen, so that is you are seeing only one side. That the same will be on the other side. Alright, so keep this in mind. So now we are talking about our quantity number 1 for excavation. So for excavation, we all know that all we need to carry out is numbers L, B and H. Now first we are talking about numbers. So let us come back to the figure. Here students, we are finding the excavation for foundation. So as you can see, there are the foundation, as I have told you that there are 2 sides of Hume culvert, one you are seeing and one exactly on the opposite. So the number of foundation will be 2. Now talking about L, B and H. So let us talk about L. So in the plan you can see that at below the ground level 120 plus 1000 plus 120, all the dimensions are in centimeter, so 1.2 plus 1 plus 1.2. But for the foundation you always know that 15 centimeters are extra, so 0.15. So that is how we can get the length. So length will be 3.7. Now let us talk about the B. B stands for width. So in the sectional elevation, you can see that the width of the foundation is given as 150. So that is 1.5. And now the height or for excavation we can call it as depth. So depth is below the ground level. So again in the sectional elevation you can see below the ground level 1.2 plus 0.45, so that is 1.65. So you have two foundation for Hume culvert. The length is 3.7, width is 1.5, and the height is 1.65 below the ground level. So putting all the values in our table measurement sheet, and we will get the quantity as 18.32 cubic meter. So I hope we are very much clear about how we can calculate the quantities for Hume pipe culvert. Students, the quantities of excavation, brickwork, sand filling, these are the basic quantity which remains the same. The fundamental rule of calculation remains the same for all the type of structure, whether you are calculating for a building or apartment, or you are calculating for the culverts. The second was cement concrete in foundation. So you always know that cement concrete in foundation, only thickness will be changed. L, B and numbers will be the same as of excavation. So let us come back to the figure. Here you can see the thickness of cement concrete in the sectional elevation. It is given as 0.45 meter. So 3.7 meter of length, 1.5 meter of width, and 0.45 meter of thickness or depth. So we'll get the cement concrete quantity as 5 cubic meter. So I hope we are very much clear about our first two quantities for Hume pipe culverts. Now let us take the third and the last quantity, which is UCR masonry in 1:6. So the third quantity is UCR in a ratio of 1:6. So UCR stands for uncoarse rubble masonry, and that is being done in meter square. So all we need is numbers L and B. So again the length will be 120 both side plus 1000. So that will be 1.2 into 2 plus 1. So that will be 3.4, and the width of that will be 120. Let us come back to the figure. Here you can see that foundation was of 150, but now that wall is of 120. So the thickness of the wall will be 120. So that is how we can carry out the quantity. But now you can see, students, there will be pipe. So at the ends there will be no brickwork. So that area of that circles of both ends we need to deduct. So that will be pi by 4 d square into 2. So let us deduct that circles. So here is the deduction of circle, and we'll get the final quantity. So this is how we can calculate the quantities of Hume pipe culvert. I hope we are very much clear up to this point. Now students, in our construction industry, sometimes it happens that we are working with the steel structures such as steel angles and steel channels. So now let us look at the numericals based on that steel structures. Or we can say that steel roof truss. But we are not going to have the design of entire steel roof truss, because we have an entire subject of design of steel structures. So we are only going to have the numericals which involves a certain calculation of quantities. All right. So let us read the numerical first. So here is the numerical base for principal rafter angle. The question says that find out the weight for principal rafter angle 60 mm cross 60 mm cross 6 mm having 5 meter length. And again another second question in the same question, another sub question is given, that is find out the painting area for a purlin of 125 cross 75 cross 8 mm having 10 meter length. So first we need to find out the principal rafter weight having 66 dimensions and 5 meter length, and then painting area for a purlin having dimension 125 cross 75 cross 8 having 10 meter length. So let us begin our calculation with the first question. So here is the detailed figure. Here is the detailed figure for the principal rafter which we have given 60 cross 60 cross 6, you can see that the outer dimension is 60. Now the thickness is 6. So internal dimension will be 54. Here I have represented in the figure. So the cross sectional area will be that 54 mm into 6 mm plus 60 mm into 6 mm. That will be our cross sectional area. I am converting all the values into the meter. So the cross sectional area I'll get as 0.054 into 0.006 plus 0.060 into 0.006. So 6.84 into 10 raised to minus 2 meter square. Pardon me. 6.84 into 10 raised to minus 4 meter square, because it is a meter square quantity, so 10 raised to minus 4. Now we know the density of the steel is 7850 kilogram per meter cube. So if I need to find out the weight per meter length, that will be area into density. So area I have just find out and the density. So multiplying area with density will get the weight per meter length. Because the unit of area was meter cube. Area was meter square and density was kg per meter cube. So I'll get the kg per meter. So that will be 5.40, approximately 5.40 kg per meter. Now I've got the length of 5 meter. So to get the actual weight, 5.40 into 5, and that will be nearly 27 kilograms. So I hope we are very much clear that how we can calculate the weight. Now the second question was purlin, painting area for purlin. So students, whenever you want to paint in a steel structure or you want to paint an outer surface, what you get? Perimeter into length. So here the dimension was of purlin was 125 cross 75 cross 8 was the thickness. So the other two dimensions are 125 cross 75 mm and the length was 10 meter. So perimeter will be 2 bracket a plus b into length. So this is how we can calculate the painting area, which will be 4 meter square. So I hope we are clear about how we can calculate the certain quantities in steel structures or component of steel structure. Moving forward, here is another numerical based on the steel structure components that we need to find out the weight of gusset plate, that is 600 mm cross 400 mm having thickness of 8 mm. Then we need to find out the weight of main tie, which is 2 in numbers and dimensions are 80 cross 6 mm per meter. And the last is painting area, again painting area for that same tie, which we are going to find out in sub point number 2. So again let us start with the weight of gusset plate. We have got the dimension, so we can have the cross sectional area. So here students, we have the gusset plate dimensions, and to find out the weight we can simply multiply the dimensions and we are having the thickness, so we'll get the volume. So here is the volume of gusset plate. Now we know know that the steel density is 7850 kg per cubic meter. So we'll just, to find out the weight, we'll just volume into density. So we'll get the weight as 15.07 kilograms. Now the weight of main tie. So we have 2 main ties. So the dimension was 80 cross 6 and per meter. So unit length. So into 1 multiplied with 2. So that is for 2 ties. Again multiplying it with 7850. So we'll directly get the weight as 7.54 kg per meter. Because here students, it was a per meter length, so the weight will be also in per meter length. And now the painting area. So students, let us find out first painting area for one tie. One tie has 2 surfaces, so 2a plus b, 80 plus 6, 2 into 2. So and now multiplying that for 2 ties, so we'll get the value of 2 ties. So that is how we can get the weight area for painting for the tiles. So that is our second question. So I hope we are very much clear up to this point. Now students, at the last, let us see another sum based on road calculation, which we have started in the earlier. Alright, so let us see another question. So the question says that the dimension and the details of a cement concrete roads are as follows. Length of the road is 1 kilometer, width of the concrete pavement is 8 meter, thickness of the concrete pavement is 0.15 meter, sub-base thickness is 0.1 meter, and the last is that we need to prepare the estimate for the given data, and we need to assume the suitable rates for the same. So let us begin with a rough or a detailed sketch of a road based on given dimensions. So here is the detailed dimension of the drawing, that 8 meter of concrete pavement, below that there is gravel surface and CC surface, and 1.5 meter of the shoulder. So for that we need to prepare an entire estimate. So let us begin our calculation with the quantities. So the first will be the box cutting for the road. So students, the box cutting, the area will be 1 kilometer of road, so 1000 meter, and the width of pavement is 8, so 1000 into 8, 8000 meter square. Here the depth could be 150 to 300 mm depth. We are assuming the depth, so here we are not calculating in the meter cube, we are calculating in the meter square. We are cutting the area. All right, 1 kilometer in the length, and the width will be of 8 meter. All right, so that is 8000 square meter. Now the second quantity, that is supplying the loose gravel and stacking it. So students, supplying the loose gravel and stacking, now the thickness is, we can assume the thickness as 0.15, so that of 1 kilometer road, so 1000 meter, 8 meter width, and for the loose gravel the thickness is 0.15, so 1000 into 8 into 0.15, so we'll get the quantity as 1200 meter cube. Students, here only we are talking about one road, so the numbers will be always 1. Moving to the next quantity, that is, the next is spreading and consolidation of the gravel. That will be also the same. All right, so the same quantity for the spreading and consolidation. Earlier was only supply and stacking, now it is spreading and consolidation, so both quantities will be the same. Now the fourth one is cement concrete in the ratio of 1:2:4 with the 20 mm downstone aggregates, including mixing, transporting and placing. Again students, this cement concrete is going to be there at a 150 depth, so 1000 meter, 8 meter width, and 0.15, again the same. So once again we'll get the quantities as 1200 meter square. Pardon me, 1200 meter cube. There is 3-dimensional 1200 meter cube, not meter square. Alright. Now the last quantity, that is providing necessary joints in the concrete surface or the concrete road and filling it with the bitumen. We always see on the road that there are concrete joints are provided, they are filled with the bitumen. So there are two kinds of joints which we can provide. Once there are longitudinal, that runs along the length, so length is 1 kilometer, so 1 into 1000, and others are transverse. Transverse are divided with the width of the road, so that is, and the second are transverse joint. Now we are assuming that transverse joint are 5 meter at the interval of every 5 meters, so the length of 1000 meter divided by interval of 5, so there will be 200 joints. Now that will be in the span of road. So span of road was 8 meter, span or the width of the road, so that is 8 meter, so 200 joints with the length of 8 meter. So that will be that two quantities which we will get in running meter, that is the joints. So these are all the quantities which we required, but we are asking for we have asked for to prepare a estimate. So let us prepare the abstract sheet by which we can prepare the estimate. So here is the abstract sheet for the given quantities. The rates have been taken from the schedule of rate SOR, which you have already studied in the previous sessions of rate analysis. These rates you need to learn by heart, or we can carry out from the SOR. So we'll get the final rate as 49,49,700 inclusive of 5% contingencies. Yes, we have added the 5% contingencies. Okay, so that is how we can calculate the data for such details given for a cement concrete road. So this is it. That was all about in today's session. In case of any query or doubt, you can always contact me on my mail or my number. Thank you.